Morning, students. Today we are starting with a simple numerical problem in AC current, right? This is the first time we are coming with the numerical problems because when I do the numerical problems on the board, it takes a lot of time. Once we start the numerical problems, we will do only numerical problems, right? Now I am making you clear about the basic idea in physics, only basics. So this I have just closed that condition. I have written a question. An AC current is given by I is equal to 141.4 sine 314t. What is the maximum value of current? I0 we have to calculate. Frequency of the AC current we have to calculate. Time period of the AC current we have to calculate. And also instantaneous value of AC current when time is equal to 3 seconds we have to calculate. Right? The given value is what? I is equal to 141.4 sine 314t. Our standard equation of current is standard equation. Standard equation I is equal to I0 sine omega t. So when we compare this one, what is I? Instantaneous. What is I0? Maximum. Maximum value of current is also called as peak value of current, or sometimes called as amplitude of AC current. So from by comparing this itself, we can write I0 is equal now I0 that is equal to 141.4 ampere you will write. This is the answer to the first question, right? 141.4 ampere, right? Next, next is now it is sine omega t. Omega is actually matching with 314. Now we can write now omega is equal to 314. But omega is equal to 2 pi by t. That is equal to 2 pi f. Because 2 pi by t means 2 pi into 1 by t. Reciprocal of the time period is equal to frequency. Therefore, 2 pi by t is equal to 2 pi f. 2 pi f is equal to 314. Right? Therefore, f is equal to 314 divided by 2 pi. That is, this is equal to 314 divided by 2 into 3.14. 3.14 and 3 then divided, you will get 100. And this 2 and 100 when multiplied, you will get 50. Therefore, this is equal to 50 hertz, you will write. Second equation, second also you got. Then is time period. Time period t is equal to 1 by f. That is equal to 1 by f, right? Because f is equal to 1 by t and t is equal to 1 by f. That is equal to 1 by 50. That is 0.02 seconds. So in our country, the time period of AC current is 0.02 seconds. That means the AC current is produced by AC generator. In an AC generator, coil is rotating. When the coil of the AC generator completes one revolution, it will take 0.02 seconds. Right? And the maximum values of current and EMF will go 50 times upside and 50 times low side. That means 50 positive and 50 negative maximum. And 100 times the AC current and EMF will become maximum. Once in the positive direction, other in the negative direction. Am I correct? After every half cycle, the direction of the AC current is changing. And also the effect of the AC EMF is also changing. That is why AC current is a current whose magnitude is changing with the time, but direction changes periodically, we speak. Am I correct? This is that. The next one, what we have to speak is, what is the instantaneous value of current when t is equal to 3 milliseconds? So that also I will say, I will do this third question, the fourth question I am doing. So we have that. In this case, we have the instantaneous I is equal to 141.3 sine 141 into sine 314 314 314 into 3 milliseconds. 3 milliseconds, 3 into 10 raised to minus 3. This we have to calculate. What's the value of this current? What is the value of the instantaneous value of current? When time t is equal to 141 I0 sine omega t. T is equal to 3 milliseconds. 3 milliseconds is 3 into 10 raised to minus 3 seconds. But remember, this part, this angle is in radians. This angle is in radians. Radians has to be converted into, first of all, into degrees. To convert radians into degrees, you have to multiply that with 180 by 5. Therefore, this can be done equal to 141.3 into sine, right? 314 into 3 into 10 raised to minus 3 into what? 180 by 5 you have to multiply. 180 divided by 5. Now this is in degrees. Right? So when we calculate this one, pi has to be taken as equal to 3.14 only, right? Then you will get this as equal to 141.3 into sine 54 you will get. You will get sine 54. The value of sine 54 is, sine 54 can be calculated. That is equal to 141.3 into sine 54. You will have to measure from, you will have to take that from a logarithm table. Natural logarithm, natural science against a 54 degree, you will find the value of that. That is for sine 54 is equal to 0.8090 something. The whole value you will take. That multiply with 141.3, you will get the value of equal to 114.39 ampere. This question I have worked out here because you will come with this value only. If you don't convert that into angle, into degree form, then you cannot find the value of that. Right? You will calculate this much and will try to get the value of that value of sine. Then you will not get the actual value of the current. So instantaneous current is not as equal to 914.39 or 35 approximately ampere you will get. So sine of an angle given this kind of questions in AC are always in radian measures. Radian measures has to be first converted into angle measures. Then only you will have to find the value of sine of that angle. Right? Sine of that angle in degrees only, not in radians. So radians has to be first converted into degrees. So many questions are also explained here. That also will go through in this book, right? In this yesterday, this is one question. Many more questions are also explained here that you can easily understand. That's why, right? Okay. Yesterday we have talked about one physical quantity called phasor. So phasor is a very important physical quantity. Phasor is nothing but it is a line of definite length that is rotating in the anti-clockwise direction. The projection of that line, just like a particle moving in a circular path, when we studied a simple harmonic motion, when the particle is moving in a circular path or circle of reference, the foot of the perpendicular is moving up and down, and the graphical representation is a sine curve. In the same way, the phasor, when rotating the circular path, the projection of that on the y-axis, the vertical diameter, will be of the shape of a sine curve. That is what is called sinusoidal EMF or sinusoidal current. So there must be separate phasors for current and EMF. EMF phasor will be bigger than current phasor because current phasor I0 is equal to E0 divided by R. Always the current phasor is of a small length and that of EMF phasor is of large, this one, right? So we have used we use this phasor to deal with the two alternating quantities taking place in the same circuit. That also we have explained yesterday. When an AC EMF is applied across an AC circuit, a resistance, a capacitor or inductor, the resulting current is also